Okay, so here is just the definition of the linked list itself. It's probably what you've seen before, right? If it's not, just let me know and I can explain. And we're just appending values. Um, Ignore the utils and execute functions, at least for now. Here is our actual code for find nth last element. I just kind of translated this pseudocode into real code. So um, nth last pointer is none. Tail pointer is the head of the linked list. Count is 1. While tail pointer exists, tail pointer is going to equal the next. Count is going to equal count plus 1. If the count is greater than or equal to n plus 1, and then we're going to do another check if nth last pointer equals none, uh, it equals the linked list head, else it's the last pointer next. And then at the end, we're going to actually print the nth last element is the nth last pointer dot value. Now I'm going to run it and it's going to work. Or actually, sorry, I have to execute it from this file. We can see here I made n2, which means that I first just display the list so we can see 5, 7, 3, 2, 8. And then the second to last element, so obviously 8 is the last, and the second to last is 2, right? So I can make n3, the third to last should be 3, but let me just make n4 so it doesn't look the same. So like, second to last is 2, third to last is 3. So the fourth to last should be 7. We're going to run this, and it's 7, right? So now I'll switch to kind of an illustration of why this works. Okay, now to explain the algorithm itself, right? So we have the linked list 57328 for the values, just like in the code. Um, I'll have the code overlaid here so you can follow along, right? But basically, we have the linked list itself, and then we have our count variables, and we have our n variable, and we have our tail pointer, right? So when we first enter the code, um, we're assigning nth last pointer to none, so I'm just going to kind of drag it off to the side because it's not pointing towards anything. And then tail pointer is going to equal the linked list dot head, or be assigned to, so I just put it here because this is the head of the linked list. And count is actually 1. Let me fix that. There you go. Count is 1. So now, while tail pointer, which is just saying while it exists, tail pointer is going to equal tail pointer dot next. So we're going to move it over here, right? Now count is going to be 2. Okay, now we're going to check if count is greater than or equal to n plus 1. N plus 1 is 2, count is not greater than or equal to that, right? So we can just go, we don't even have to do anything. We're just going to go back up to the top of the loop because there's nothing else to do. So now, while the tail pointer exists, we're going to move it to the next one more time, and we're going to increment count one more time as well. Now, if count is greater than or equal to n plus 1, which in this case it is, because 3 is equal to n plus 1, we're going to check if the nth last pointer equals none. Since this is the first time we're getting to this block of code, yes, it does equal none. And nth last pointer is going to be equal to the linked list head, which is right here, right? So we're putting it at the beginning now. Okay, great. Now that we've done that, we go back to the top. While the tail pointer exists, it's going to equal tail pointer.next, and count is going to equal count plus 1. Now we know that this is going to be greater than or equal to n plus 1, so we can just check if nth last pointer is none, which in this case it's not, it's 5, or assign the node that contains 5. So it's not none, but so now we're going to do the else statement, which is nth last pointer is nth last pointer dot next, right? Okay. So now it's going to be assigned to 7. We're going to go back to the top. Tail pointer exists, and so we're going to increment it. Count is going to go up. We're going to enter that conditional statement because it is greater than or equal to n plus 1. Nth last pointer does not equal none, so we're just going to increment this again. Now we go back to the top of the while loop and we increment tail pointer up to the next. Obviously next, there is no more nodes, so the next is going to be none, right? So tail pointer is none. And count is going to be 6. All right, great. So now that count is 6, um, we can do the conditional, which is true. If nth last pointer equals none, which it does not, um, nth last pointer is linked list dot head, right? And then else, we're going to move it forward to this one containing 2. Now, this is while tail pointer. Tail pointer now, it's pointing to nothing, which means while tail pointer is equated to false, right? Um, so this equates to false, which means we don't enter the loop whatsoever, and we're just returning. Now we have this nth last pointer pointed to 2, and we can do basically just whatever we want with that, right? Because we don't have to do anything else. We have the value we need, right? This is the second to last. So now we have 2, and in the code, I just have it print the whatever n is last element is the value of the nth last pointer. So in this case, nth last pointer, the value is 2. So it's going to print 2. I hope that makes a bit more sense. If it doesn't, let me know, and I'll try to help explain it.